Hello, welcome to the, I guess, Alucard from farmer to table, yeah, right this time, meeting. We're going through Alucard code, getting it from, the code that we see down here into this form. And, we have some expansions here all the way down to vamp-ir. I already kind of started covering def type. The first file we go to is alu.list, because that file is the front end of the language where we actually start things. And we're starting by macro expanding some stuff. Great. Okay. Okay, we can
And
continue.
is vamp-ir consumed by a crypto component already, or is there some further intermediate step before the Rust crypto code takes over?
Yeah, there's a language called vamp-ir. It can parse this, I hope. There's no compiler for it yet.
It aspires to.
Yeah, it aspires to parse this and then compile this to WASM for us. So it will do this for us. It'll compile it via
and that's
Plonkish library at first.
And that's the crypto team that's doing that part?
Joshua. It's Joshua.
Right, okay. Is it in Rust?
Yes. Yes, it is in Rust. Yeah.
And so there's a spec posted somewhere of the vamp-ir?
Mostly, there is a BNF, but the BNF isn't like there's a BNF used for parsing, which is not the same as a BNF used for reading. So I had to read it and interpret it when I was reading through it. So this is right.
I mean, Terence, what do you want to know exactly? Do you just want an overview of the language, or do you want to know the details of how it's implemented for vamp-ir?
Probably the details of how vamp-ir itself is implemented are not, I'm guessing,
so
super important to me, because that's like a purely crypto ZK snark thing, right? As opposed to something I would directly be writing. It was more I was asking more to just understand how all the big pieces fit together, so that I understand.
I see.
Yeah,
the significance of what I'm looking at any given moment.
But I mean, vamp-ir is just essentially 3 files of 100-ish lines of Rust code at this point. So you could as well just go through the code and see what's happening.
Okay.
But yeah, there is a repo, and there is a README in the repo.
Yeah, I think I linked it in my README. I have a README that I've updated at some point, and I mentioned vamp-ir. You have to go to a branch, the development branch, if you open up this. Is that on buffer 2? If you look here and you go to development, I think. Yeah, you go to development. And here you go, 12 days ago, and you can see that there's 22 commits in it. This is the one that you'll want to read. Let me just link this in chat. There we go. Cool. 5.
So vamp-ir is essentially a representation of some polynomial constraints, and then the vamp-ir compiler converts that to a Plonk circuit. Is that a valid?
Yeah, pretty much. Well, it's not just Plonk, but for now it'll be Plonk. It'll be Plonk with lookup gates at first, I think, because lookup gates are really handy for what we're doing. But yeah, it's supposed to be backend independent. So I make claims often about Alucard being backend independent, so this thing can compile to whatever constraint system that you care about, because vamp-ir can. It's meant to be like the prism that spits out too many backends. You're shining a light through a prism, it fractures everywhere. It's like that.
Gotcha.
Yeah, cool. There's no compiler for it yet. I'm waiting on breath something. I don't know how the analogy goes, because what I can do then is have a REPL for vamp-ir code, for Alucard code, as soon as vamp-ir has a compiler. So I can't wait for that to happen for just usability of Alucard's sake, because it'll make Alucard a lot more usable than it is right now, I think. Anyways, so yeah, so that's what kind of that does. So you add it to storage. You can see the macro expansion. A good way of looking at these front-end macros is literally just macro expand the form itself and just look at it. And if it looks right, it's good, right? You can just kind of see okay, defun name. So notice the name is used again, but this time we don't have it be the keyword version of it, or the keyword version just turns it to a symbol. I ensure it's called by value. This is important. This makes it so that everything is in kind of ANF form before we begin. So like I end up gensimming a name and letting it and omitting it. So there's a thing called omitting instruction, which I'll get to in a bit. But basically, I'm forcing it to be a use once reference. So it'll generate a reference rather than doing the computation again. This typically matters because you may get a record here, but the issue is that you don't want to pass a record around to a common Lisp function, because there's Alucard functions and then there's common Lisp functions. And because at the moment I don't do a little trick that I mentioned in the Alucard room, like this weekend, I didn't think about it. It's a really good trick. If you were to, just pass a record, it would pass the computation over and over and over again, right? Which is really not what you want, right? You want to be a call by value language. And so this thing ensures that it's called by value. It's as simple as that. I'm going to show you how this works in a bit because it's kind of important understanding how instructions work in the language at the moment. Okay, cool. Besides that, the call is really basic. You just make a record. The name is the name, and then from all the fields which come in, the fields are the field names which are given, which in this case is x plane, y plane, and z plane. It just makes them, right? We map can, meaning that we're flattening out the list, and then this like inlines it, and we get this make record. The name is 3D point. X plane is x plane. Y plane is y plane. Z plane is z plane, right? With the x, y, and z being keys, right? It's like it's a bit of code, and it does so much for us. It allows us to have records. Which is really nice, I think. We can call it right now, and I can even show you. I think it's Aluser. I always spell it with one too many U's. 3D point, and X plane is a 5, Y plane is 10, and Z plane is 30. And you see we get back a reference because this is I don't know where it is. Let me just look at my emit code. And this is like stored in Alu emit circuit body. It's stored here, and you can see we get the record back. I'll show you why I do this in a bit, but it's important. But you can see that this just kind of works as you expect. Yes, Terrence?
Storage, that lasts for the duration of what? Translating a single Alucard module into vamp-ir?
No, actually, it's all live. That's why I can pipeline right now. There you go. Storage lasts forever until you restart the system. You can kind of view it like a Lisp environment where when I define this function here, it adds it to the environment, and now it's just there until I kill my image. And I can dump the image and have all these things stay there, if that makes sense.
Right.
So you can cache your entire program just by say dumping a new image of Alucard, and boom, all your circuits are there.
Right. Okay.
There are ways of clearing storage, I think. I may have to add extra things to remove things from the hash table, but it's just a mutable hash table is what storage is. I'll get that after this macro. We'll finish up this macro. And finally, I have one last thing. I make the accessors. I just map car over the field. If the field is bound, here's a little trick. I check if the field's bound because I don't want to have multiple def defuns in a file, and even multiple def methods kind of can error out a file. So I just try to make the least number of def methods as possible. This means that if someone else takes its name, it's not going to generate out a method for it or whatever. I could probably do something smart by setting a flag saying if it's already been generated in storage, and error if it's not the one in storage, but I don't. I just ignore it if it's not there. This is bad design on my end. So that's what I do. It's bad design. And then I just return the name. And this is the entirety.
So if you end up with,
yeah,
sorry, if you end up without an accessor for a field name because there's already a record with that name,
that's fine.
How do you? So do you just refer to it anonymously by writing out the entire?
So if there's two records with the same field name, they just overlap because they're just generic. Whoops, I'm an Aluser. It just creates that. I'm gonna look at it just does a lookup on whatever the data is. This will fail type checking. This will fail type checking.
Ah, okay.
So we can, so the accessors are generic and they work for any data as long as they have the slot. You can look it up. So you can kind of view it like a lens in a sense. But if someone takes its name in like a function, yeah, that is an issue. That would be an issue. I have that issue myself because I have like a function called time, which I don't use it anymore, but like a loser has time, and this actually conflicted with time from common list.
Okay.
You know, it's like CL time, which is wonderful. But yeah, no, it is an issue, and I should fix this by yelling at the user. I should tell them what's wrong, right? This to me is bad, all right? But you know, it's really easy code to change, right? It's as easy as setting a new flag in the environment and then checking if this is like, oh, if there's already a generator, a getter made for it, you know, you check that the flag is made by us. If it's not made by us, warn the user that, hey, this thing conflicts with another function. Maybe you want to like do something about it, right? So we can do that. We can do a restart system on that. So that's cool. So that's the entirety of def type. You know, this high level looking idea is that simple, right? If we just expand it, it's really just at the end of the day, we don't generate out the functions because they're already generated out. So that's why there's 3 nils this time. And yeah, it's that simple. Does anyone have any questions about like the def type macro itself? Okay.
Don't think so.
Cool. I guess I'll go over what storage does now because that is a good question. What is the storage nonsense? Like what is storage? I don't know. Let's find out today. So storage is really basic. It's a type. So I have a thing called types and functions. The types is a hash table from keyword to type storage. I think this would be spec. I can't jump to it. That's annoying. But there is a function called type storage in here, which we can go to type, I hope. Type storage, let's just write it. There you go, I can jump to it here. So type storage, it's a primitive or a type declaration, right? Where what's a type declaration? It has a name, generics, options, or declarations. It's kind of like the things that we were seeing before, right? That we were kind of generating. It just has like, it's just, you know, we're making a type declaration. That's cool. It's that or a primitive. A primitive just has a name because I don't know what a primitive is. It's just a name, man. And because of that, whoops, where was I? I can just do another jump back. I can go back. Cool. So that's what's stored in the types table. For the functions, it's stored in the functions table, which, you know, function type is either a primitive or a circuit. A circuit has names, it has arguments, it has a return type, it has some body, which is the frozen literal of the syntax, and we'll get to that in a bit, and it has an execution body, which is the real body, which we'll get to when we talk about emitting. So it's just 2 hash tables.
What do you mean by a frozen circuit literal?
I'll show you. When I do def circuit like this, I'm going to show you what I do. I literally freeze the syntax. Where is my quote? Right here. This is all frozen. Like there's a def here which turns into this.
You mean it's not evaluated?
Exactly. It's literally frozen. It's like I put a tick over it, which makes it frozen. I'm going to eval it later because it's my trick of preserving the original syntax. And then when I want to re-update the body, I just eval it. Like I just run it. This is probably bad. There's 2 things I should do. I should store this, but I should eval it on the spot for better error reporting. So this is something that can be improved. Because you're going to get error messages when you eval it, which is probably not what you want. You probably want to go through with it, even if the definition is not ready yet. Common Lisp should just warn you about the value not being defined yet, rather than me do anything. So, you know, this isn't perfect, and it can definitely be improved. I think I have an issue somewhere about that. But yeah, that's all. That's what the frozen literal is.
Actually, I have a question about freezing too. What's the difference between, or when would you say freeze as opposed to quote?
Oh, I just use it as like, you know, when you put a lambda over something, you freeze it. It's kind of in the same sense. Like I could have just put a lambda over this and then called the thunk.
Okay, I see.
I should have probably done that, actually. That'd be more efficient than calling eval. To be quite honest. But because I want to inspect the syntax, because it's really nice when I look up a circuit from storage pipeline, I get to just kind of see it. And if I had a thunk here, I couldn't see it.
Right.
Yeah, so yeah, so it is quoting. Sometimes I call quoting freezing, because the way that I visualize it is that you're freezing it in place, and then comma resumes it, typically. So yeah, I kind of use them interchangeably.
Okay.
That's a reference. Yeah. Oh, so I hate this printer. This printer is bad. I could do so much better now that I've learned. So don't copy my formatting issues here. Yeah, and so there's also another thing called an entry point. Get entry point set. I have no entry point yet because I haven't evaled it. This is like the canonical main of your function. There's an easy way of setting it. There's a canonical function table and a canonical type table. You don't have to worry about these too much. These just let me swapping. And then there's some API on it, right? This API is very useful, but all I'm really going to show off today is like lookup function, lookup pipe. Like they work as you expect, right? They're just mutating the global hash table, right? That's all they really do. And that's what we're doing when you look up the function. Notice it gives us back a circuit. It is the type that we expected, is a type circuit. It has arguments, body, execution body, all that of what you expect. If we storage, lookup type. And I also notice here, I actually store them by the keyword. I don't use namespaces in Alucard yet. This may be a bad design choice, but I'm using the keywords to store as the keys. You maybe want to move it to symbols if users start using multiple packages, so they can have different modules with Alucard code. So this is a potential improvement that would be like a few line changes, right? It'd be really, really easy to fix this, right? Let's see what 3D point. And you can see here, we store it like this, and we can see what it was. We can see a declaration. The declaration has an order, all that. Great. I hope the storage kind of makes sense now, how storage kind of works. It's kind of useful because often you'll see me just run the pipeline after looking up something from storage. So I hope like the conceptual model makes sense. It's just 2 hash tables. It's nothing fancy. Okay. Cool. That's stuff type. There you go. You know how we ingest types now. We'll get down to the compiler. Well, that's pretty much all we do with types. So I think we got types pretty much out of the way, besides like type checking and all that. Here's like the function which defines a circuit. It's also really basic. As you can see, it's just a matter of 39 lines of code. This gets just the arguments. All I do is if this thing is a type of privacy, a privacy is either private or public. All right, you can see here that when we do def circuit, it's either private or output. So I have to filter out the output. I'm basically filtering out, hey, if this thing's an output, please don't leave it there. So I'm removing if that. So these are just the arguments. The names are the cotter of it. You can see it's the second. Okay, great. The output is just going, I'm doing remove if instead of remove if not. I'm checking if there's more than one. If there's more than one, by error. This is a bad error message. I should do better. This is very bad of me. I get the key name, which is just turning the name into a keyword, and I just make the lexical variable of it. So I technically do this. So I'm trying to make it a list 1. I think this is wrong of me. So if we do L2 norm by hand, if we do a loser L2 norm by hand, I also make it this here, just like a name. I think this is wrong of me, though.
When you say that message is bad, are you saying something like you should say which arguments the user made outputs?
Yeah, I should say what, and I should check that they're actually outputs and that they didn't misspell something. Like there could be a lot more. There could be a lot better handling of it here. Yeah, and this one's easy to do too. And this one actually is like one of the easier error messages to get right. We'll see down the compiler that I need to really track more information about like locations and whatnot, and I need to hack in Common Lisp to do it. I would ideally like help or something, just because like it's going to be tedious for me just to look through Common Lisp documentation to try to get it like get the Swank commands and making sure that it works. I have some plans in my mind, but it's tedious. But yeah. So yeah, I make def. I make a function by the name, call by value. I make application. We're doing the same trick again. We're making an application. The application takes the function, and then I have the argument names. And that's why when we do loser, L norm, you can see that it takes a P here. It actually remembers the name in it. There's something better I can do as well. I should be able to add documentation strings. I don't do this yet. We should add, hello, this is a documentation function gets the square root of P. I don't do this. I should do this. Anyways, I make an application. I add the function to storage. I emit a let ref over it because I want to let the names like P over it. That's why you saw it before in the expansion of this. There is a let ref before the freeze. That's what this does. So that's all. Yeah, and we emit the last instruction. Cool. Does like def circuit make sense? Like def circuit's really basic. It doesn't do much, right? It just adds a thing to a storage, and it makes a lexical variable version of it and a function version of it, along with adding it to the storage. Not bad, right? Like
P over it meaning something to do with predicates?
Oh no, the P is the name of the argument coming in. P is the argument, private P int. We can see it here with this one. I do input. This one takes input. It's the name of the argument of the circuit.
Oh, I see. Okay, so the let refs thing that's generated by a
Yeah, let me just expand it. It just does this.
Okay.
It just expands it to a make reference of the name and allows it to be used within this. So I'm doing tricks to allow it to use commonless scoping. I'm using commonless scoping for all of this.
Right. Okay.
I just rely on the language. I don't need to worry about scoping. It just works. Yeah. There's better ways to do all this. I have an issue opened, issue number 30, if anyone's curious. I'm trying to, I have a def form, which we'll get to in a second. It's completely unneeded now that I thought of a technique this weekend. So I'm kind of happy I can reuse commonless blet and remove def from the language. So that'll be fun. Easy stuff. I haven't finished defgate yet. Wait, it is done. Wait a second. It's almost done, but yeah, I should use defgate already. This thing's cool. Notice that currently we have to give the type of the circuit. I don't use defgate anywhere in here because it's not ready yet. But notice that I give the type along with the privacy. What defgate will do is just allow that, and I can also add inference because I know what the type of these things are often. So ideally, you should just be able to say input, and it should infer the type. And if it can't infer the type, what I want to say is sig is int or intable. I want to say this in the future. This is a really easy change, and I think this will make a huge quality of life improvement to the language. So if everyone's interested on this, we can do this together. It won't be hard, actually. But this would make a huge difference, I think, in writing the language.
Yeah, that'd be educational.
It's just some macro writing. That's why I just haven't done it. I'm too lazy. That's basically the issue. This def function just does let bindings. This is unneeded. This just makes it so that when I do a def, here, I'll show you. Where do we do a def? It's really basic. I don't want to do a def circuit one. I want to do this one. Cool. So if we go in here and I macro expand it, I just make let refs. I can make let refs for foo and bar, meaning that they're useful. And then I eval the bodies. So I make a let node of the var. And the val is this array function, right? It's just what it is, right? And it just does this for all the values of let. And then we just call the body with foo and bar and scope. And you can see here that it's a bunch of code, but it's not that bad. It's let refs. We just car out the values. If it's a let constraint, we do something special because def constraint allows me to do nonsense. So I allow it to do nonsense. But besides that, I then generate out bindings, and then I just, check if the body is length 1. If so, get the car. Otherwise, list it. Okay. That's all it does. The entry point sets the entry point of the circuit, so I know which thing to generate when you dump a file. That's kind of neat. I have def primitives. This isn't really used for user-facing code, but this isn't for me. I can just add a primitive this way. Same with primitive functions. That's cool. Coerce. So these are functions which just are you can use in the language, right? Like if I were to go to loser, I can just call coerce. Let's say 32 to int 64. And if I look at my emit, it generates that out. Neat, right? So these are all that's required to add a new form to the language. Just do ensure call by value, and then just fill out the record form that is there, right? You can assume that every primitive in the language just has something like this, where I have a class. I just have a class for it, and I just have a structure. That's really that easy. Just define a new structure, add it to some type, to figure out where the compiler complains about inexhaustion. And there you go. You add to the front end just by making one little macro to do the parsing. Basically, it's that simple. Yeah, that's pretty much what all these are. It's just me doing macros. With constraint is a bit more in touch because I don't know things, but it's not too bad. And that's basically the front of this file. I guess I'll cover emitting now, unless anyone has a question about, I guess, how we get the front-end user code. Because all this is the front-end user code. Like, it's just a bunch of macros. The user can write these themselves if they really wanted to. I don't expect them to, but you could do this yourself and it wouldn't be too difficult, I guess. You can use my primitives and build stuff on top of, like, your own new primitives, which I have some plans for as well if anyone's wanting to do that with me. I would love that. Yeah, does anyone have any questions besides the emit stuff? We'll cover that now, I guess, and kind of how that works, because we're getting to that point where we care.
You can move on as far as I'm concerned.
Okay, cool. So I have this thing, which I often called ensure by volume, and it makes a thing called, like, emit. And it emits a let, and then I just make the reference out of it. Okay, that's cool. But what is this emitting nonsense? Why am I emitting? What is this? First, let's figure out what it is, and then we can figure out why I'm doing it. Is it good? Is it bad? I don't know. So I have a global variable called circuit body. As you see that, I'm kind of like showing off here. It's a listen nil. This will be important later. And when I add an instruction, when I say insert instruction, it takes the coulter of this and sets it. It sets the coulter to the term that we give in and sets the circuit body. It sets the coulter to the term that we're passing in, and it sets the circuit body, which is the thing itself, to the coulter of what it was previously, right? So it sets. You can imagine that this is a mutable list, and we have a reference to a list. And I'm going to store a name with it. In this case, when you're just using it on the top level, it goes away. But you can imagine if I bind it like with this, this is a dynamic variable. So if I were to let a new name for it, it'll mutate this thing. So what I often do is I let the circuit body be some list that I give in. So if we have like some def parameter x be a list of nil, and I mutate this list, it'll actually add to it. The circuit body itself will be a reference to the last element of the list, meaning I can push to the end of this list X immediately just by taking the coulter of it, setting it to be the list of the term, and then setting the circuit body, which is the reference to where it is in the list, to the coulter, right? I hope that kind of makes sense. I know that's like a really roundabout way of describing it, but we can kind of visualize it. If you have like two lists, so this is X, right? Where circuit body is, it is basically here, right? This is where circuit body is. And when I push a new element to the list, circuit body, I push a new element to circuit body, I mutate this 4, because circuit body is a reference to it, to be 5 now. Like I add, say, 5 to it, and then I set the circuit body to here. That's all that's happening in this code. It's kind of confusing because I'm using mutation here. But does like the model kind of make sense of how circuit body like emitting works? I just increment to a list. And to bind the list, I did this thing called with circuit body, which creates a fresh circuit body. So you pass in your list. It then lets the circuit body be the circuit body over the body. So anytime you do an instruction, it adds it to this list here. And then I set f this init body to be removing the null, because you're going to put in null as a placeholder to start off the list, because you need some list to start off with. And so that's how I kind of do it. And that's what emitting has kind of been doing. And you can kind of see me use with circuit body often in here. It's and I just like have a little list that I set and then I keep around.
Could we see the previous function in action?
Which function in action?
The one above instruction that you were just showing.
Oh, you mean with circuit body?
Yeah.
Sure. Let me see. Where is a good one? Here. So on the def form, I don't care about def form. Where is def circuit? Def circuit, I should be using. I don't, because I admit it.
No, wait. It wasn't you do def macro instruction somewhere.
Yeah. Well, I can show you on here where with constraint. How about that one? With constraint makes a circuit body. It calls the thing above it, which is this. We can see it there if you want.
Yeah, this one. Yeah, this one. Yeah.
Great. So let's do this. Let's just call with constraint. I could call it by hand, but let's just call with with constraint x1, x2. I'm just gonna assume I'm in prelude plus x1, x2. Great. So let's kind of macro expand this. So what it does is that makes the list a nil. Here, let's copy this. We can just macro expand it. I just have to change the name of it. No define reference for G. Oh, yeah. No reference for G. It's complaining because it doesn't like the fact that there's like a hashtag on it. Great. Okay, great. So this works. So let us like figure out this. So let's not use this G anymore. Let us set parameter X to be a list. And I think this will set it as well, because this thing's the same pointer. We can see that X kind of got all the values, because when we did this let rat and we did the prelude plus, if we look at this, I don't think it's a macro. Oh, it is a macro. But it generates out a function called ensure call by value, which, as we saw, calls in make instruction, in this case, an application. Yeah, let's kill this as well. Let's see if I can REPL. And so this thing will emit an instruction, which will add it to the circuit here, right? It'll add it to the X, and when we look at X again, yeah, we have, because I didn't finalize it, I actually did some things. Yeah, it works, I think, as intended. Yeah, it adds it to the new one, because I technically am changing how X is with it. Yeah, because I'm just passing it the full list. Yeah, that makes sense. The interesting thing is that, as you can see, with circuit body gives it this list, meaning that this is now what it's mutating, because it does this. So let's macro expand this even further. If I macro expand this, it generates out this, right? So if we expand this, I have to do this by hand. Yeah, it does this, right? It lets the circuit body be G1108, which is our X, and then it calls the function in it. This does a dynamic variable binding in Common Lisp. Dynamic variables mean that it takes the one closest to the code being executed. So it actually takes G1108 and not the global version of it. And then I just set it to remove the nulls, and then I get it. Notice that I set G1108. I don't set X to remove the nulls. So that's why X still has the nulls. Because I'm having an indirect reference to it. Because I'm not literally mutating the list, I'm just filtering it. Does that kind of make sense, like how it kind of works? It just kind of like moves some pointers around.
Yeah, so when you do with circuit body, this is mutating something that will still be in scope outside of the with circuit body, right? This is not just something which is in scope.
Yeah, I'll just mutate a list so that we pass it, and that list will be the thing that it's living on above this, right?
Right,
We're passing
right,
in a
okay.
reference for it to mutate.
Okay. Yeah.
And now the question is, why am I doing this? Why don't I just do a normal? Yeah.
Sorry, have we seen the code yet which generates the name, the G1108?
What do you mean by generates the name?
Oh, like if I do this repeatedly, will it be is with circuit body? Oh, I see. So with circuit body already took G1108 as a parameter.
Exactly.
It's not the thing that's keeping track of like what the next available name is. Okay.
Exactly. Yeah. It just has a list and it cutters down it and sets itself. So yeah, there's no name generation by it. It literally just finds it.
Right. Okay. So by the time that function actually got called by the compiler, it would have generated a name somewhere else.
Yeah, someone already put a name in it. With constraint, technically put a name. Not with constraint. With constraint, put a thing with circuit body. It generated it here when you call with constraint. Just does it for you. It is Jensen. And Jensen's nice. Gives me a name. Cool.
Oh, and so Jensen must have some. Wait. So does Jensen have some context that you can set, which tells it like what the form of the name is, or is that just like a default?
I can give it a name like hello.
Okay, I see. Got it.
Yo, Mac. This is x.p. I actually do this for more things. I don't do this enough. So a thing to keep note: my def does not use Jensen. It should. This is bad of me that I don't use Jensen for name generation in the language sometimes. It's why you see code with that isn't Jensen. Notice this thing doesn't have a Jensen name. That's bad.
Oh, yeah.
Legitimately, that is bad and will cause conflicts in the user code. If they want to break me, they can, because I don't Jensen it. That's a really easy fix. You just in def. I can maybe make this homework. Figure out how to make this Jensened. It's really basic, and I want you to preserve the initial name. And you can see that Jensen takes an argument to do that, so it's actually not hard. Cool. Yeah, I should do it. I'll make it homework though for someone. Everyone's interested. But yeah, so that's how knitting works. I do this, but the question is, why do I do this? It seems kind of weird. I talked about before, like, yeah, well, if I pass it to a common list function, it's going to have weird behavior. I thought of a way around that recently, right? I can keep track of what are the unique objects and let them once for each unique object. So that's not really an issue anymore. But the issue lies in the following. What if we did the following code? Map-par and x. I wonder what plus we have. Let's go. What plus is this? This is common list. When I said prelude plus 3, 4, and then this, I know that this code is pure, right? I could technically ignore it. Right? Let's just say x and x, right? The issue is that this plus gets ignored. But if I emit it to a body, then this x doesn't get ignored. It acts as if you've called it. So I hope it kind of makes sense why I'm doing this really weird imperative thing of like emitting to a body, as we say it. Like, although this computation is pure, what if it wasn't? What if this does some constraint binding in the language? What then?
How do you mean? How do you mean? Could you elaborate a little more on what the question is?
So we could, for example, say range gate. This is a range gate of, say, 2 by x. So we're saying that x is within, like, 2. This constrains what x is. This has an effect. This has a declarative effect on x, giving more information about the type of x. I don't have this function, but you can imagine that, like, this doesn't get done, right? Like, this code goes away. This code is not kept. You see, we only have 4 references here. We don't have 8. We do 8 operations in here. And you can imagine that if this is range gate, all of the effects of the range gate would go away if I don't emit to a body. If I just keep it functional, I just keep the syntax as is, and I see what's in my arguments and consider that to be what we do, then this range gate here, if you imagine this as a range gate, would just go away.
So if you did replace that with range gate, the number of references that it spit out would it be like 5? A different one from the range gate free?
It'd be the same. We throw it away. We throw out the range gate if we don't emit. If we emit, there is a difference. For example, I can actually show you. This is actually a good example of showing this off. Let us do emit. What is it? Emit with circuit body. Okay. Emit with circuit. With circuit body. I want a name for it, so let me actually wait a second. I can just X. We can use X. We already have X. I think it takes that, and then I take this. And notice what X is. X is now all this. Notice we have 8 things in this list. We don't have 4, we have 8. Because we emit to the body, this plus 2x is kept. X in this case is 1, 2, 3, 4, right? I hope that kind of makes sense. If we did it functionally,
I see.
the map car only returns the last thing in the lambda. It doesn't return both.
Yeah, I see.
And so I do this imperative thing to keep the language consistent with everything else. Like you expect it to have an effect, so we make it have an effect. Right. Yeah, so that's why we emit. So I hope that makes sense. So we have some emitting to the real body, and when we make the circuit, all the elements will emit to the real body. Makes sense, right? It'll emit to some list. As you can see here, it gets added to this list. And now we can finally begin going into the compiler. This is just the front end. So does, like, I guess user parsing make sense? So we parse it with some macros, then we emit some code. I guess we freeze it, but you can imagine that it emits some code to a list, and now we're ready to compile. We have everything that we need to compile in this like 280 lines of code or so. Yeah. That's about it. Like, again, these are just simple macros. So that's cool. The place that we go after this is passes, because now we're ready for passes. I usually look at the package file to figure out.
Jeremy, would this be a good point to stop, because I'm gonna have to jump to a different call?
Oh, yes. We should probably pick this up though at some point, just because well, we're just now to the pipeline going down. So yeah, we should do this at a different time. What time is best for you all? Same time next week? Actually, wait, will I be here next week? I will. We can do this weekly if you want, or we can finish this sometime this week as well.
Yeah, we can schedule something tomorrow or the day after, or I'm okay with it, as long as Terence also is okay.
Yeah, Terence, are you fine with
Yeah,
that?
I mean this same time of day, I think either tomorrow or Thursday would work for me. Probably, let me see. Maybe probably Thursday might be a bit better, but they would both work, like whichever one you would prefer.
Can we do it an hour later? Actually, no, because there is an Alucard meeting an hour later on Thursday. Are you free Wednesday? Did you say Wednesday was fine?
An hour later, Wednesday, maybe?
Yeah.
Yeah.
Or is that too late? Is that too late for you, Ajinkya, or does that work?
No, it's fine.
Okay.
No, I scheduled this time because of because 4 p.m. clashed with this other meeting.
Right. Okay.
This time is fine.
Okay.
Cool. But yeah, no, we can call it a day here. I'll stop the recording. I hope this recording was useful. I'll close it
thanks.
in our channel.
Yeah.
Stop recording.
All right.